Hi! Today I am going to cover about the topics Ampere's law to determine the magnetic field from a solenoid or a toroid, but in this case I'm going to talk about the solenoid only. As you have seen that the list of topics that are going to cover in the finals, so I went through the holidays textbook, the chapter of 29, and I think that this is a really good problem, and I hope it will appear in the exam. So yeah, that's the reason that I picked this problem. So I'm going to talk about the tips before taking the physics exam. So I came up with some process for me in solving each of the physics problem. And first of all, I would just look into all of the necessary values like that is given in the problem. So first we can say that the turns of the solenoid, and we can also see the radius. But then we have seen that there are two currents. So this is starting a confusion in our problem solving, because normally there's only one, but in this case there are two currents and it has the milliampere and the ampere. So we can name it differently so that to avoid confusion, we can name this as smaller I and this is bigger I. So after this, we can also continue and see other numbers that are significant to our problem solving, and we can also see another degree, the angle. So we can also see that there are some of the units that are not standard yet. Therefore, we have to change all the units into the standard measurements for physics, because like in some other subjects, for example chemistry, sometimes we don't actually use like liters and milliliters, so there are like grams and kilograms, so it's different in physics. So make sure you check before solving each problem. Therefore you can feel the confidence that you're doing the right calculation, and you don't have to waste your time to recheck it again at the end of the exam. So next step is to draw if possible, or you can just imagine it in your head, but for a safer side, you should like draw a picture of what's going on in the problem. Ta-da! Okay, so after having the picture, we should also name each of the components as well, because as I said, that picture gives you the idea of what's going on. Because if you're like reading the letters only, you would like feel what is the problem is about. You might not know what's going on. So I think the picture is more of a giving you a better idea of imagination. So here we change all of the units that are not standard. Therefore, when you pick the values for the calculation, you can just pick the values that you already change the measurements. Alright? And also don't forget, the smaller I belongs to the solenoid and the bigger I belongs to the long conductor. Okay. So I've done the calculation, and I want to explain about the formula. So the formula we are finding the radial distance. But why are we using this formula? Because the only formula that is connected to the radius, it is like having the relation with, is the magnetic field. So we pick this. However, we do not know the value of this one. Therefore, we need another help from another formula. So this is the reason that I think it's quite tricky and it might appear in the exam. Yeah. So you wonder why they gave us the angle, because the angle is useful for this one. And why is BS over BC? Because in the trigonometry, oh my god, it's not a right triangle. It's supposed to be a right triangle, okay? According to, I wrote a book, I think something about To All the Boys I've Loved Before or something. I forgot. Or another book. I remember the girl said this one, and I searched it out on the internet, and it's very useful for me. I could like use it till university. Yeah. So T stands for 10. Oh my god. T stands for 10. Not the tens from Ayers. It's tangent. Oh my god. I see this word. I remember from the drama. Yeah. So this one is O. What does O stand for and what does A stand for? So O stands for opposite and A stands for adjacent. Why am I keep writing the wrong word? Opposite, and this is the adjacent. So here we go. We have BS as the opposite and BC as the adjacent. And here we have the two values that are equal because tangent of 45 degrees is 1. So we cancel everything that is similar and we have this one remaining. So therefore we can find R in this problem. Ta-da! So I have already pre-calculated. So the value is 4.77. In this case, you can keep it as M or keep it as centimeter. It depends on the problem. If they require you to change the unit measurements, you have to change. But if they don't require you, you can just keep what it is. That's all. Next, they need you to find the magnitude of the magnetic field. It is not the direction. We do not need this. This is called vector. And this is the magnitude of the vector. So we are finding this one. So I have pre-calculated as well, but I want to show why we have this value. So it is because of this thing. B total is equal to Bs. I'm pretty sure you have seen of this because it is the Pythagorean theorem, and you can just simply take square root of 2 out because of this one that we have found earlier in the previous question, that Bs is equal to Bc. So we have root of 2 as the factor, and we calculate the inside of the remaining stuff. But the remaining stuff, we can either use this one or this one that we found earlier. The answer will be exactly the same. So here it is, because it is equal, right? This is the answer of this one. Thank you.